can we multiply vectors by numbers? And the answer is yes. So let's just see an example of that. If we want to multiply v by 2, so 2v, I'll just write it like this, 2v. Component-wise, this is just 2 times this vector, which we just take that 2 and we multiply each component by it. So this becomes, I'll write out each step here. This is 2 times 1 and then 2 times 2, which of course simplifies to 2, 4. The vector 2, 4. And we call 2, this number 2, we call it a scalar multiple. And there's a good reason we call it that, because what it does is it scales the vector. Oops. And let me show you that. Here is our original vector, just v. Here is 2v. It's twice as large. In fact, let me put regular v back. You can see there's v, and when we multiply by 2, it makes it twice as long. It changes the length by 2, by a factor of 2. Okay, there's nothing fancy about that. We could also check out what happens when we take v and we multiply by a half. It makes it half as big, half as long. What I really want to talk about is what happens when we take v and we multiply it by -1. Well, then it flips the direction of v. Now v is going in the opposite direction. And what happens to the components? Well, that's relatively easy to figure out. Oops, I didn't need to erase those. If we take -1 times v, which I'll just abbreviate it as -v, this is -1 times 1, 2, which simply turns out to be -1, -2. And it flips the direction of v. And why is that so important? Well, now we can talk about vector subtraction. We have a -v here, and we know this works because we can multiply by that scalar of -1. And now we have a way to talk about vector subtraction. So let's go ahead and do that. See you then.